In this video, we will be reviewing over Ohm's law. Ohm's law was developed by George Ohm. Ohm's discovered the proportionality between current and voltage, and we're going to be looking at this as how we can approach solving various problems involving resistance, voltage, current, and even power. Experiments show that for many material, including most metals, the resistance remains constant over a wide range of applied voltage or current. This statement has become known as Ohm's law. Ohm's law can be stated as the change in voltage equals the current times resistance. Ohm's law was the result of the work of Ohms, the result of Volta, and amperes. Ohm's law is an empirical relationship and is valid only for certain material. Material that obey Ohm's law are said to be ohmic. Resistance is a measure of the opposition to the flow of charge and is measured in ohms. Now, the symbol for ohm is this right here, and I want to show you that when we have a circuit drawn, this is the symbol for resistance. Here we have the symbol for battery. You can see the current. Current is in amps. Voltage, volts is in voltage. And then this is the form of Ohm's law that we use quite often, where we have our current equals our voltage divided by resistance. The current will be in units of amps. Voltage will be in units of volts. Resistance will be in units of ohms. If a problem discusses resistors that are in parallel or in series so that you can see what they look like, here we have batteries that are in parallel. Here we have resistors that are in parallel. Here we have resistors that are in series. And here we have batteries in series. So you can get a visualization as the problem is discussing what is in parallel and what is in series. So that Ohm's law is a basic algebraic problem where we have current equals voltage divided by resistance. Obviously, we can rearrange the formula multiple times, and so we can get it with resistance equals voltage divided by current, etc. Now, do remember resistance is in ohms, voltage is in volts, current is in amperes. And so here we have just the rearrangement that you can see as you approach the problems. Now, I did all of the problems as current equals voltage divided by resistance, with one of the components being X, and solving for X, and it was a very simple problem. Here you have some practice problems if you'd like to try to do these. I do want to mention one problem. It's problem number 7 on your homework, and it says, what is the increase of current when 15 volts is applied to a 10,000 ohms, which is adjusted to a 1,000 ohm value? And so what we did for finding the increased current, I solved for current with the 10,000 ohms, and it had 15 volts divided by 10,000 ohms, and I got my current. And then I solved for my current where it was adjusted to 1,000 ohms. So I had my current equal 15 volts divided by 1,000 ohms. And then to get the increase in current, I subtracted the difference between the two. And that was the extent of the difficulty of the problems for Ohm's law. When we look at resistance in Ohm's law, two wires of the same length and diameter will have different resistance if they're made of different material. And this is a property known as resistivity. And the definition of resistivity is using this symbol right here, P, so that our resistance would use this formula right here. In this formula here, this right here, this is the Greek letter rho for resistivity. So we can get our resistance by taking our resistivity. This right here is the length of the wire, and then this right here is the cross section. The units of resistance would be in ohms for your answer. As stated, different substances have different resistivities, and so I've got some of those on the chart here for you. And so you can clearly see that difference between the insulators, the semiconductors, the conductors, and then their resistivities. In general, we can say that the resistance of material goes up as temperature goes up due to thermal effects. This property can be used in thermometers, and resistivity will decrease as the temperature decreases. But there's a certain class of materials called superconductors in which resistivity can drop suddenly to 0 at a finite temperature. And this temperature is called the critical temperature, and it is symbolized big TC. So the value of the TC is sensitive to chemical composition, pressure, and crystalline structure. Once a current is set up in a superconductor, it persists without any applied voltage because the resistance is 0. Electric power is symbolized capital P. The electric power in a circuit is the rate at which energy is absorbed or produced within a circuit. A source of energy such as a voltage will produce or deliver power while the connected load absorbs it. The quantitative symbol for power is P, and it's the product of voltage multiplied by current, with the units of measurements being in watts. So our equation, we have our power equals our current times voltage. Power is in watts, current is amps, voltage is in volts. And so if you are asked to solve for a problem such as a blender is plugged into a 110 volt outlet that supplies 2.7 amps of current, what amount of power is used by the blender? You will then just take your current times your voltage, and you'll be able to get your power. If, however, current is not given, we can have a substitute equation where our power equals our voltage squared divided by our resistance. And so if we are given voltage and resistance, we can still solve for power. And so that's the extent of the problems that you will be running across as you go throughout your ohms and powers worksheet. You will be using 3 formulas. This right here, power equals current times voltage. This right here, power equals voltage squared divided by resistance. And then the current I equals voltage divided by resistance.